So in this video, I'm going to run through some percentage yield calculations, which commonly come up on paper too, on the organic side of the course. And the general formula for percentage yield is very straightforward. You just take the actual yield, so the mass that you obtain when you do the experiment, you divide it by the theoretical yield, the mass that you should have obtained, and to get it as a percentage, you're going to multiply it by 100. So we'll just look at an example. So here below, I've got a reaction. I'm reacting hydrogen with chlorine to make hydrogen chloride. And before I can calculate the percentage yield, I'm going to need to work out the theoretical yield. How much should I get? So if I'm starting off with 5 grams of H2 and I've got an excess of chlorine, how much HCl should I get in grams? So to work that out, it's just a typical moles calculation. I use my moles table, work out the number of moles of H2. When I know the number of moles of H2, I can use the ratio to work out the number of moles of HCl. And now that I know the moles of HCl, I can work out the mass as 182.5 grams. So if I start with 5 grams of H2, I should make 182.5 grams of HCl. So that is my theoretical yield. However, for a couple of different reasons, it's rare that you actually convert all of your reactants into products. So you might just have a reaction that doesn't go to completion. So some of the hydrogen just doesn't end up colliding with the chlorine and it just doesn't react, or you haven't left it for long enough, or you haven't heated it enough, and not all of the hydrogen's converted. And if that's the case, you're going to get you're going to get a yield that's lower than 182.5. In other reactions, you sometimes have a case where there's competing reactions and you end up making something that you weren't intending to make. So you get a side product that you weren't intending to make. In other reactions as well, where you've got purification steps, you can lose a little bit of your product in each purification step, and then at the very end you end up with a mass that's smaller than what you intended. So let's just say in this particular example that even though we know we should get 182.5, that at the end, when we get the mass of our product, we see we've only got 180 grams. So that will be our actual yield. And you'd be told that in the question. You'd be told this is what they actually get. You work out the theoretical, and then to get your percentage yield, as I said, it's the actual, which is 180, over the theoretical, 182.5, and you times by 100, and that's going to be your percentage yield. So we'll just do one more example. I'm going to get you to press pause and have a go at this for yourself. So this is kind of what the question would look like. So using the same equation as I have above, so I'll just write it again here. So the student is making HCl by reacting 10 grams of H2 with an excess of Cl2. So you've got 10 grams of the H2. The student obtains 300 grams. So the amount that the student obtains, that is the actual yield. And they ask you to calculate the percentage yield. So just like I've done, you first need to work out the theoretical yield. So just use your normal moles table, work out how much the student should have made, and then you'll take your actual, divide by your theoretical, and multiply it by 100. So just have a go at that for yourself. All right, so I've just filled in my moles table here. I'm starting off with 10 grams. The formula mass of H2 is just 2. So I've got 5 moles of hydrogen. Using the ratio, that should produce 10 moles of HCl. And then 10 times the formula mass of HCl gives me a theoretical yield of 365 grams. So if everything went according to plan and all that hydrogen reacted, I should get 365. But I'm told in the question that I'm only getting 300. Therefore, my percentage yield is going to be 300, which is my actual yield, divided by 365, which is my theoretical yield, and I times it by 100, and I work out what my percentage yield is going to be. So another way they can ask this question is they'll tell you how much HCl that you want to make. So I'm going to say we want to make 365 grams of it, and they'll tell you what the percentage yield is for the reaction, and they'll ask you to calculate how much hydrogen you should start with. So again, you're going to start off with just your simple moles table between HCl and H2. So given information about HCl, I'm asked about H2. They're the two things I'm going to include. I can leave chlorine out completely. And I'm trying to make 365 grams of HCl. So I use the formula mass of HCl in order to work out how many moles of HCl I'm trying to make. And then I can use my ratio to work out how many moles of hydrogen I need to make, and then work out the mass of hydrogen that I should start with. So if I had 100% yield and nothing was going to be lost, then starting with 10 grams of hydrogen would give me the 365 grams of HCl that I want to make. But you're told in the question that you don't have 100% yield, you've only got 80% yield, and that means 20% of your product is going to be lost. If I'm going to lose some of it along the way, I'm going to need to start with more than 10 grams. So with that number, with the 10 grams, and with the percentage, 80%, okay, you're going to need to do something with these two numbers that allows you to get an answer greater than 10. And this is where students typically go wrong, okay? What they'll do is they'll take the 10 grams and they'll get 80% of 10 grams, and then they'll write down that the answer is 8 grams, that you should start with 8 grams if you're trying to make 365, okay? That's wrong. Theoretically, we should be starting with 10 grams. If you know you're going to lose some of it along the way, then you have to be starting with more than 10 grams, not less than 10 grams. So if you're doing this calculation and you're ending up with an answer less than in theory, what you should start with, then you've made a mistake. So instead of getting 80% of the 10 grams, what I'm going to do instead is I'm going to take my 10, I'm going to divide by 80, and I'm going to multiply by 100. So if I was getting 80%, I would divide by 100 and multiply by 80. But in this case, I'm doing the opposite. I'm dividing by 80 and multiplying by 100. And when I do that, I get 12.5 grams. And that's reasonable, okay? I know I'm going to lose some of my product, so it makes sense that I'm starting with more H2 than I originally planned. So just do your moles table exactly as you've done before. Work out, in theory, what you should start with, and then use the percentage to make sure you end up with a bigger number. So I'm dividing by the percentage and I'm multiplying by 100. Okay, so I've got a similar question here. Press pause and have a go at this one for yourself. So I'm saying you're trying to make 146 grams of HCl. You know the percentage yield is only 50%. What mass of Cl2, so I've just changed from hydrogen to Cl2, but it doesn't change how you're going to do things. What mass of Cl2 should you start with? The formula mass of Cl2 is 71. Okay, so I started off by doing my moles table. If I'm starting with this, so if I want to end with this mass of HCl, then using my moles table, this is the mass of Cl2 that I should start with, 142 grams, okay? But that would be fine if I had 100% yield. That would give me the 146 that I need. But when I've only got 50% yield, I'm going to need to start with quite a lot more Cl2 than I originally planned to take into account that I'm going to lose 50% of it. So again, common mistake here is students just get 50% of 142 and they write their answer 71 grams. That again makes no sense. You're starting with less than you need, even though you know you're going to lose half of it, which makes no sense. Your final answer has to be bigger than 142. So again, what I'm going to do is divide by the percentage. So I'm dividing by the 50 and I'm timesing that by 100. And when I do that, I get an answer of 284 grams. So you'll see I need to start with quite a bit more Cl2 than I originally worked out to take into account that I'm going to lose 50% of it along the way. So 284 will be your answer. Then the final way that they can ask this question is they tell you what you're starting with and they tell you what the percentage yield is and they ask you for the mass of the product. So how much product are you actually going to get if I start with this amount of H2 knowing that this is my percentage yield. So again, if I'm starting with 10 grams of H2, I'm going to work out the mass of HCl that I should get. So I should get 365 grams if I had 100% yield. They tell me I don't have 100% yield, I've only got 50. So this time I do want my answer to be smaller than what I've just calculated. If I know I'm going to lose half of it, then I'm not going to end up with 365. I'm going to end up with 50% of 365. So this time I'm going to be dividing by 100 and multiplying by 50. So the opposite of what I did in the last one. And when I do that, I end up with 182.5. And this is the mass of HCl that I will get if I start with 10 grams of H2, because I know I'm going to lose half of my product, so it should work out as being half of the theoretical yield that you calculated. In all of these, I've found mass, and then I've done the percentage calculations with mass. You could also do it with moles, so I could take the 10 moles and I could work out the 50%, so I would get 50% of 10 moles, so it's obviously 5 moles, and then I would do 5 multiplied by the formula mass, and I would get exactly the same answer. So it doesn't matter if you use the percentages on the mass or on the moles, as long as you're giving your final answer as mass. So I'm going to find some exam questions just to show you what this looks like in the exam. Okay, so here's an example from the exam questions. It's about an organic reaction between butanol and hydrogen bromide to give me 1 bromobutane and water. And this reaction was given to you in an earlier part of the question, and they're telling you that the student is starting off with 0.150 moles of the alcohol, and they tell you what the percentage yield is, and they want to know what the mass of 1 bromobutane is. So again, what I'm going to do is I'm going to draw out my moles table, and I've got my alcohol, I'm just going to write it as alcohol, as my reactant, and I've got my haloalkane as my product. Alkane. And in this case, you don't even have to work out the moles of the alcohol because they've told you the moles straight off, so 0.150. I can see from my balanced equation that the ratio between them is 1:1, which means if I start with that number of moles of the alcohol, I should also produce that number of moles of the haloalkane. You do have to work out the formula mass of the haloalkane, so you'd have to count up the number of carbons, hydrogens, and the bromine and work it out. And when you're working at formula mass, you should always use the mass numbers to 1 decimal place. So I work out the formula mass is 136.9. When I do that, 136.9 times 0.150 equals 20.535 grams. Okay, so that's the mass of the haloalkane that I should get. But then they tell you that you've only got a 61.4% yield. So I'm not actually going to get that mass because I'm going to lose some of it along the way. And they want to know the mass of the 1 bromobutane that you actually obtain. So I'm going to take that number, the 20.535, and I'm going to get 61.4% of it. So I'm going to divide it by 100, and I'm going to multiply it by 61.4. And when I do that, I get an answer of 12.6 grams. So it asks for 3 significant figures, so 12.6 grams. So exactly the same as what we have been doing, just a slightly harder equation with the formula mass slightly harder to calculate. But you do the same as always. You work out what you should get in theory, and then you're going to use your percentage yield to work out how much you actually got. So I've got another question here. Again, it's an organic reaction. You're dehydrating alcohol to turn it into an alkene and water. And you're told that the expected percentage yield is 62.5%. They tell you that you want to make 4.20 grams of the alkene, and they want to know, well, how much alcohol should you start with if that is your desired mass of the alkene at the end. So again, I'm going to start by drawing out my moles table. And I'm going to have my alcohol on one side, that's my reactant, and I'm going to have my alkene on the other side. I know that I want to make 4.20 grams of my alkene. Again, you do need to be able to work out the formula mass. You need to be able to count up the number of carbons and hydrogens you've got in this chemical formula. And when you do that, you should find out that the formula mass is 84. And then I can use that to work out the moles, which is 0.05 moles. The ratio between the alcohol and the alkene for my equation is 1:1, which means if I want to get 0.05 moles of the alkene, I should be starting off with 0.05 moles of the alcohol. Formula mass of the alcohol, again, you would have to work that out for yourself. And that means 5.1 grams, that's the mass that I should be starting out with, okay? But then at this point, I need to use my percentage. This is the mass that I would start out with if I had 100% yield and nothing was going to be lost. But I know my yield is only 62.5%, and that means I should be starting with a greater mass of the alcohol. So again, when I take that number there, the 5.1, and I take my percentage, 62.5%, at the end, I need to have a number greater than 5.1. So don't get 62.5% of it. You will end up with a smaller answer than 5.1. I need to divide by the percentage itself, by the 62.5, and then times it by 100. And if I do that, I will end up with an answer bigger than 5.1. I end up with an answer of 8.16 grams. And that makes sense, okay? That's how much I should start with, but because I'm going to lose some along the way, I actually need to start off with a greater mass than I originally calculated. The rest of these questions they're all done in the same way, and they come up a lot in chapter 16. So if you're looking for more examples, go and have a look in the chapter 16 booklet and just practice doing a few of them for yourself.